When Atlas was first detected, it represented only the third such visitor ever observed by humanity, a unique messenger from beyond our Sun's gravitational dominion. Initially, it was believed that this enigmatic traveller would execute a harmless, distant flyby, offering a fleeting glimpse into the composition and characteristics of matter from another star system. Scientists eagerly anticipated gathering data from its swift passage, expecting a trajectory governed purely by the known gravitational forces of our celestial neighbourhood. However, in a turn of events that would ripple through the scientific community, ATLAS began to defy these very expectations. Observers noted a subtle yet persistent deviation in its path, a course alteration that was both unprecedented for an object of its presumed nature and deeply perplexing. This wasn't merely a minor perturbation, it was a distinct and undeniable change in direction, guiding the interstellar object onto a trajectory that converged with the orbit of Mars. The quiet anticipation of a distant scientific study quickly gave way to a growing sense of astonishment and concern, as the data solidified this unexpected new reality. The significance of an interstellar object changing its course within our solar system cannot be overstated. Unlike comets or asteroids born within our Sun's sphere of influence, which can be nudged by planetary gravity or outgassing, ATLAS was a visitor from another star, expected to follow a hyperbolic path largely undisturbed. This substantial and seemingly purposeful shift contradicted established astrophysical models, raising immediate questions about the forces at play. It implied an unknown variable, a factor beyond the simple pull of gravity, guiding this cosmic wanderer. As the days turned into weeks, the data consistently confirmed this startling new orientation. ATLAS was now undeniably heading towards Mars. The red planet, long a focus of human exploration and scientific endeavour, had become the unexpected target of an interstellar visitor on an altered course. The initial comfort of a safe, academic observation evaporated, replaced by a profound and unsettling uncertainty. This once harmless guest was now approaching with an intent that no natural celestial mechanics could explain, setting the stage for a dramatic unraveling of its true nature. The first signs of this profound deviation began to emerge in August of 2025 as a persistent and growing anomaly in the object's expected path. Astronomers who were meticulously tracking its journey noticed that the tiny discrepancies in their calculations were not random errors, but part of a consistent and cumulative trend. Day after day, the observed position of ATLAS strayed further from the path that gravity alone had dictated for it. What started as a statistical curiosity soon became an undeniable fact, confirmed by observatories across the globe. The object was actively moving away from its predicted trajectory. With each new set of observational data, the projected future of ATLAS was rewritten in a more alarming light. The mathematical models, once showing a safe and distant passage, now illustrated a dramatic and steady shrinking of the flyby distance to Mars. The gap between the interstellar traveller and the red planet was closing at a rate that defied simple gravitational mechanics. This transformation of a secure, predictable event into an alarmingly close encounter created a palpable sense of urgency within the scientific community, as the focus shifted from passive observation to active threat assessment. In their quest for an explanation, analysts identified the source of this change as significant non-gravitational forces acting upon the object. This term describes any influence beyond the pull of the Sun and planets, a ghostly hand pushing the object off its natural course. Such forces are not unheard of in our solar system, but the magnitude of the influence on ATLAS was exceptional. It was clear that a powerful external process was continuously altering its momentum, providing a sustained push that was fundamentally reshaping its journey through our celestial neighbourhood. The most immediate and logical suspect for such behaviour was cometary outgassing, the process by which frozen gases on a comet's surface vaporize as it nears the Sun, creating jets that act like natural thrusters. However, this conventional explanation was quickly ruled out. The anomalies in the orbit of Atlas were far too powerful and, most tellingly, far too precise to be the result of the random and chaotic venting of sublimating ice. The force was being applied with a consistency and directionality that suggested a mechanism far more controlled than any known natural cometary activity. The persistent deviations in the object's path were a profound scientific anomaly, as they did not conform to any known models of natural cometary behavior. The subtle, random pushes from outgassing create a characteristic wobble or drift in a comet's orbit, but the changes observed in the trajectory of Atlas were different. They were smooth, sustained, and directional, suggesting a force that was not only powerful but also applied with a high degree of control. This led to the inescapable conclusion that the object was being subjected to a continuous, directed influence, a phenomenon for which there was no precedent in the annals of astronomy. As the data was further analyzed, the true scale of this maneuver began to reveal itself in the stark language of orbital mechanics. The calculations pointed to a potential total velocity change of up to 10 kilometers per second, an immense alteration in the object's momentum. This was not a minor nudge, but a massive course correction, more than sufficient to transform what was once a harmless, distant pass into a direct and unavoidable collision course with Mars. The precision of this change was as startling as its magnitude, as it systematically erased the margin of safety with each passing day. The energy required to execute such a maneuver was simply staggering, far exceeding any known natural process for an object of its estimated size and mass. The chaotic venting of sublimated gases from a cometary nucleus could never generate such a focused and powerful thrust over a sustained period. This glaring discrepancy between the observed behavior and known physics forced researchers to look beyond conventional explanations. The energy expenditure was so immense that it pointed towards an artificial origin, a technological capability far beyond anything humanity possessed. This line of reasoning inevitably led to an unsettling and revolutionary speculation that the object was not merely drifting through the cosmos, but was being deliberately steered. The idea that this interstellar visitor was, in fact, a vessel under intelligent control was a profound and deeply challenging notion. It moved the event from the realm of natural disaster to something else entirely, a potential first contact scenario unfolding as a direct threat. This very notion challenged humanity's most fundamental understanding of its place in the universe, suggesting that we were no longer just passive observers of the cosmic dance. The calculations that attempted to quantify the strange forces acting on ATLAS began to converge on a critical figure. The data suggested that a total velocity change, or delta V, of approximately 10 kilometers per second was being enacted upon the object. In the vast scales of interplanetary travel, this is an immense alteration of momentum, a maneuver that requires a colossal expenditure of energy. It was a number that lay far beyond the realm of any known natural cometary process, which might only produce a change measured in meters per second, not thousands of them. This specific value was profoundly significant because it represented a celestial tipping point. It was the precise amount of course correction needed to transform what should have been a distant and uneventful passage into a direct and certain collision course with the planet Mars. The object was not just wandering off its path, it was executing a maneuver of a specific and sufficient magnitude to guarantee an interception. The abstract anomalies in its orbit now translated into a tangible and unavoidable future impact. The sheer impossibility of a natural process generating such a powerful and precise maneuver inevitably led the scientific community toward a quiet but deeply unsettling speculation. When all conventional explanations fail, the mind is forced to consider the unconventional. The sustained, controlled nature of the trajectory change, coupled with the immense energy required, strongly suggested that the object was not merely drifting subject to unknown forces, it was being actively and deliberately steered. This was no longer a passive rock, but an object under intelligent control. This hypothesis, as fantastic as it seemed, was the only one that logically fit all the available data. The object's behavior was not chaotic. It was methodical. It was not a random tumble through space. It was a guided flight. The idea that this interstellar visitor was, in fact, a vessel or craft of some kind was a profound departure from all previous experience, a notion that challenged the very foundations of humanity's understanding of its place in the cosmos. The implications were as awe-inspiring as they were terrifying. In light of these revelations, all prior assumptions of a safe and uneventful passage were rendered completely and irrevocably obsolete. The initial models, which had been built upon the predictable and well-understood laws of gravity, were now worthless. The initial categorization of 3I/ATLAS as a fascinating but ultimately harmless interstellar comet had been a profound misjudgment, based on a set of rules that this object was actively rewriting. The sense of scientific security that had accompanied its discovery had entirely evaporated. The object that was once a fleeting curiosity, a welcome messenger from another star system, had now transformed into a subject of grave and immediate concern. Its approach was no longer an opportunity for passive study, but a developing crisis of unknown proportions. This enigmatic visitor was no longer a simple wanderer, but an active and unpredictable entity. As its impossible, guided journey brought it ever closer, telescopes and probes turned to scrutinize its physical form more intently, soon revealing a series of strange behaviors that were every bit as baffling as its change of course. As the interstellar object continued its impossible journey toward Mars, the focus of observation shifted to assets that could provide a closer view. Among the most crucial of these was the Mars Reconnaissance Orbiter, a veteran spacecraft that had been faithfully circling the red planet for nearly 2 decades. With its powerful suite of scientific instruments, the MRO was perfectly positioned to capture high-resolution data as Atlas approached. It was during one of these observation windows that the orbiter registered an event that was as sudden as it was inexplicable. In a single, fleeting moment, the object's brightness instantaneously doubled. The data received from the MRO was clear and unambiguous, ruling out any possibility of instrumental error. The phenomenon was not a gradual brightening, like that of a comet warming as it nears the Sun, but an abrupt and uniform increase in its overall reflectivity, or albedo. The scientific community immediately sought a plausible, natural explanation for such a dramatic event. The leading hypothesis was a massive fragmentation or outburst, where a significant portion of the object's surface might have carved off, exposing a vast, fresh plain of highly reflective ice that had been previously hidden from view. However, this conventional explanation began to crumble under closer scrutiny. A natural fragmentation event of that scale would almost certainly have been a chaotic process, creating a visible cloud of dust and debris, and likely resulting in an uneven brightening across the object's surface. Yet the data from the MRO showed a clean, coherent event. The entire object simply became twice as bright, as if a switch had been flipped. Furthermore, such a violent outburst should have imparted a new, unpredictable momentum to the object, but its trajectory remained unaltered, continuing on its precise and controlled course. This singular event served as another powerful piece of evidence that ATLAS was not behaving according to the known laws of nature. The combination of a perfectly controlled trajectory with a sudden, uniform increase in brightness strongly suggested an artificial process rather than a random act of celestial mechanics. It was less like a comet breaking apart and more akin to a deliberate change of state. This stunning visual anomaly was merely the first indication of the object's strange activity, a prelude to even more mystifying signals that were about to be detected across the electromagnetic spectrum. The mystery of the sudden brightening deepened almost immediately as other instruments aboard the Mars Reconnaissance Orbiter registered a simultaneous and equally perplexing event. Concurrent with the visible light flash, the orbiter's ultraviolet spectrometer detected an intense and unexpected surge of UV radiation emanating from the object. This was not a subtle fluctuation, but a powerful burst, an invisible torrent of high-energy light that accompanied the visible doubling in brightness. The discovery added an entirely new layer of complexity to the phenomenon, indicating that this was not merely a change in the object's surface reflectivity, but a significant and energetic event. In the cold, dark vacuum of space, such an intense emission of ultraviolet radiation from a presumably inert body is profoundly anomalous. Natural comets and asteroids are not known to spontaneously emit high-energy UV light. They primarily reflect the sunlight that falls upon them. The energy signature detected from ATLAS was of a different character altogether, suggesting an active process of energy release was occurring on or within the object itself. This energetic discharge was far more significant than any known chemical reaction that could occur on a cometary surface, ruling out yet another potential natural explanation. The presence of this ultraviolet radiation fundamentally changed the interpretation of the brightening event. It was no longer plausible that a simple fragmentation had exposed a reflective sheet of ice, as such a mechanical process would not generate a corresponding burst of high-energy photons. Instead, the data pointed towards a powerful energy conversion, a process that released its signature across multiple wavelengths of the electromagnetic spectrum. Scientists were now faced with an object that was not only capable of controlled propulsion, but also of generating and releasing significant amounts of energy in a sudden focused burst. This silent, energetic signature was a profound puzzle, a clear signal that the object's physical properties were as unnatural as its orbital mechanics. The twin phenomena, the instantaneous doubling of brightness and the simultaneous surge of ultraviolet radiation, formed an inseparable and deeply strange pairing. They were two facets of a single deliberate act, an event that defied easy explanation and pushed the boundaries of known physics. The quest for understanding now shifted from simply tracking the object to attempting to decipher the very language of its emissions, hoping to find a pattern in the unfolding mystery. As observatories and space probes continued their intense scrutiny of the approaching object, the analytical focus shifted to spectroscopy, the science of breaking down light and other forms of radiation into their constituent parts. This powerful technique allows scientists to identify the precise chemical composition of distant celestial bodies by reading the unique signatures left by different elements and molecules. When the light from ATLAS was analyzed in this way, it revealed another startling and deeply unnatural characteristic. The object was releasing methodical, periodic bursts of carbon dioxide gas into the surrounding vacuum of space. This was not a constant or chaotic stream of gas, as one would expect from a sublimating comet. Instead, the spectroscopic data revealed a perfect and unwavering rhythm. Every 17 minutes, precisely, a concentrated plume of carbon dioxide was ejected from the object. This clockwork-like regularity was profoundly out of place in the natural cosmos, where phenomena are governed by the elegant but often irregular forces of nature. The 17-minute cycle was too fast, too consistent, and too precise to be explained by any known orbital resonance, rotational period, or geological process. The implications of this rhythmic outgassing were immense, pointing directly towards an artificial and mechanized origin. A natural body does not behave like a metronome. This was the signature of a machine, a system operating on a fixed, repeating schedule. The timed release of gas suggested a functional purpose, perhaps related to heat management, a propulsion system, or some other internal process that required regular venting. It was the sound of a cosmic engine, its steady beat echoing across the void, and providing the most compelling evidence yet that this was no ordinary interstellar wanderer. This discovery of a precise, repeating chemical pulse added another layer to the growing mountain of evidence that ATLAS was an object of technological origin. The controlled trajectory, the sudden doubling in brightness, and the accompanying surge of ultraviolet radiation were now joined by a rhythmic heartbeat of carbon dioxide. Each new piece of data reinforced the others, painting a coherent and increasingly unsettling picture of a controlled, powered, and purposeful vessel. The mystery was no longer simply about where it came from, but what it was designed to do. The discovery of the rhythmic carbon dioxide pulses was a watershed moment, but it was the analysis of their direction that transformed the scientific understanding of the object's behavior. By carefully observing the Doppler shift in the spectral lines of the gas and modeling its interaction with the solar wind, researchers were able to determine the precise vector of each expulsion. The results were both astonishing and deeply unnerving. Each pulse of gas was not being vented randomly into space. It was being directed with pinpoint accuracy, focused into a narrow plume aimed squarely at the orbital plane of Mars. This was the final, irrefutable piece of evidence that explained the object's impossible trajectory. The rhythmic pulses were not merely a byproduct of some internal process. They were the process itself. Each carefully timed and directed burst of carbon dioxide was acting as a form of low-thrust propulsion, a gentle but persistent push that, when repeated every 17 minutes, was capable of enacting the massive velocity change that had been observed over the preceding weeks. The non-gravitational forces that had so perplexed astronomers were now revealed to be the workings of a sophisticated and deliberate engine. The precision of this targeting was the ultimate testament to the object's artificial nature. A natural comet, subject to the uneven heating of the sun, would produce jets of gas from random points on its rotating surface, resulting in a chaotic and unpredictable tumbling motion. Atlas, by contrast, was exhibiting the hallmark of an advanced guidance system. It was maintaining a stable orientation and using its periodic thrust to make methodical, fine-tuned adjustments to its course, perfectly aligning its path with that of its planetary target. The implications of this discovery were profound and inescapable. This was no longer a matter of speculation or interpretation. The data provided a clear and coherent picture of a guided vessel executing a controlled and purposeful maneuver. The object was not simply heading towards Mars by chance. It was actively and intelligently navigating its way there. The rhythmic pulse of its engine was a constant reminder of its technological origin, a steady beat counting down the moments to its inevitable arrival. While spectroscopic analysis revealed the secrets of the object's emissions, another technology was brought to bear in an attempt to understand its internal structure: deep space radar. By transmitting powerful radio waves from large antennas on Earth and analyzing the faint echoes that returned, astronomers could create a rough model of an object's size, shape, and composition. When this technique was applied to ATLS, the returning signals painted a picture that was once again entirely inconsistent with that of a natural comet. The echoes were strong and sharp, suggesting they were bouncing off a solid, highly reflective surface. The data from these radar observations pointed to a startling conclusion. The object possessed a dense, metallic core. Unlike a typical comet, which is a porous agglomeration of ice, dust, and rock, the signals from ATLS indicated a central structure of significant mass and high density, consistent with a large, solid piece of metal. This finding directly contradicted the dirty snowball model of comets and presented a fundamental paradox. The object was venting carbon dioxide like a comet, but its internal structure was more akin to a metallic asteroid, a combination of characteristics not found in any known class of natural celestial body. The presence of a massive metallic core offered a potential explanation for some of the object's other strange properties. Such a core would provide the necessary structural integrity to withstand the immense forces generated by its high-speed, guided trajectory and repeated thruster firings. A fragile, icy body would likely have disintegrated under such stresses. Furthermore, a dense central mass could logically house the very machinery and power source required to generate the energy for its propulsion system and the observed ultraviolet emissions, providing a physical anchor for its technological capabilities. This discovery added a crucial piece to the accumulating puzzle. The object was not just a guided projectile, it was a robustly constructed one. Its external behavior, characterized by controlled flight and rhythmic pulses, was now matched by an internal composition that suggested durability and purpose. The metallic core was the hidden heart of the machine, a dense and enigmatic center from which its unnatural actions originated. The image of a fragile, icy wanderer was now completely replaced by that of a solid, powerful, and purposefully designed craft. With the confirmation of a dense metallic core from the deep space radar reflections, scientists were able to create a much more accurate estimate of the object's total mass. This calculation combined the object's observed size with the newly understood density of its composition. The resulting figure was staggering, placing the upper estimate for the mass of Atlas at a colossal 10 billion tons. This was not the weight of a simple space rock or a porous ball of ice. It was a mass on a geological scale, concentrated into a single, guided entity. To place this number in perspective, 10 billion tons is thousands of times more massive than the largest man-made structures on Earth. It is a weight that dwarfs the entire fleet of satellites humanity has ever launched into orbit. The sheer scale of such an object suggested that it was not merely a probe or a scout ship, but something far more substantial, a mobile structure of almost unimaginable proportions. The very idea that such a massive body could be an artificial construct was a profound challenge to human conceptions of engineering and technology. This immense mass fundamentally altered the perception of the object's capabilities and the potential consequences of its journey. The energy required to propel and steer a 10 billion-ton vessel with such precision is astronomical, implying a power source and propulsion system of immense sophistication and output. The controlled, rhythmic pulses of carbon dioxide were not just a curious signal. They were the workings of an engine powerful enough to maneuver a body with the mass of a small mountain, a feat of engineering far beyond the current limits of human science. Furthermore, the combination of this tremendous mass with its high velocity endowed ATLAs with an extraordinary amount of kinetic energy. As it continued to accelerate towards its target, it was no longer just an object of scientific curiosity, but a projectile of immense destructive potential. The initial concerns about its trajectory were now amplified by the understanding of its sheer physical substance. The silent, guided approach of this 10 billion-ton metallic body represented a threat of a magnitude that was difficult to fully comprehend. As the global effort to understand the enigmatic visitor intensified, another long-serving Martian orbiter, the European Space Agency's Mars Express, made a pivotal and deeply strange observation. While imaging Atlas with its high-resolution stereo camera, the probe captured something that had previously gone unnoticed. 3 small, distinct points of light in the immediate vicinity of the main body. These were not faint, ambiguous smudges, but sharp, shiny dots, glinting in the sunlight as they travelled alongside the 10 billion-ton object. This discovery was a complete surprise, adding a new and complex dimension to the unfolding mystery. What made this observation truly extraordinary was not just the presence of these smaller objects, but their unwavering spatial relationship to one another. The 3 shiny dots maintained a perfect equilateral triangular formation as they moved through space. This was a geometric precision that simply does not occur in nature. Debris from a natural fragmentation event or a cluster of captured asteroids would drift and tumble under the complex gravitational influences of the Sun and Mars, their relative positions constantly shifting. These objects, however, were locked in a rigid and unyielding pattern, as if connected by invisible struts. The mathematical improbability of such a formation occurring by chance and remaining stable over time is astronomical. The laws of celestial mechanics dictate that any loose collection of objects will inevitably disperse or fall into a chaotic orbit around their parent body. The fact that these 3 points of light held their perfect triangular arrangement was a clear and unambiguous sign of artificiality. It was not the result of chance or gravity, but of active and continuous station keeping, a deliberate act of formation flying that requires constant energy and control. This discovery fundamentally changed the perception of the approaching threat. Atlas was not a solitary vessel. It was the central component of a system, accompanied by what could only be interpreted as smaller, coordinated craft. Were they probes, escorts, or something else entirely? Their purpose was unknown, but their presence was undeniable. The lone, enigmatic wanderer was now revealed to be a flotilla, a silent and disciplined squadron moving with a unified purpose. The mystery had deepened, and the complexity of the approaching entity had grown exponentially. With the object's physical parameters now understood with a chilling degree of certainty, its immense mass, its high velocity, and its unwavering collision course, the nature of the scientific inquiry shifted dramatically. The focus moved from observation to prediction, from cataloguing the object's strange properties to calculating the precise consequences of its arrival. Around the world, supercomputers at various space agencies and research institutions were tasked with running sophisticated impact simulations. Their purpose was to translate the abstract physics of the encounter into a concrete and understandable measure of its destructive power. The results of these independent simulations began to converge, painting a grim and consistent picture. The models predicted that the kinetic energy released upon impact would be equivalent to the detonation of 2 million megatons of TNT. This is a figure of almost unimaginable scale, a quantity of energy so vast that terrestrial comparisons struggle to lend it meaning. It represents a force tens of thousands of times greater than the largest nuclear weapon ever conceived by humanity. An explosive power that belongs not to the realm of human conflict, but to the domain of planetary creation and destruction. Such an immense release of energy would not be a localized event. It would be a planet-altering cataclysm. The initial impact would vaporize the 10 billion ton object and a vast portion of the Martian crust in a fraction of a second, creating a flash of light and heat that would momentarily outshine the sun in the Martian sky. This thermal and kinetic shock would be followed by a seismic wave of colossal proportions, a tremor that would not just shake the ground, but would propagate through the very core of the planet, fracturing its lithosphere on a global scale. The finality of this number, 2 million megatons, left no room for ambiguity or optimistic interpretation. The approach of Atlas was no longer a scientific curiosity or even a potential threat. It was a mathematically certain catastrophe of the highest order. This single, terrifying figure became the focal point of the crisis, the data point that transcended scientific debate and entered the realm of immediate and existential concern. It was the number that would serve as a catalyst, transforming a period of quiet observation into a frantic, worldwide effort to respond to a danger that was now fully and terribly understood. The simulations that predicted a 2 million megaton energy release were not just abstract calculations, they were detailed models that sought to translate this colossal force into tangible, physical consequences. One of the most fundamental outputs of these models was the size of the impact crater that would be carved into the Martian landscape. The consensus among the various independent analyses was stark and unambiguous. A direct hit from the 10 billion ton object, travelling at its terminal velocity of 57 kilometers per second, would excavate a crater approximately 60 kilometers in diameter. This was not a scar, it was a wholesale reshaping of the planet's surface, a geological event on a scale not seen since the primordial bombardment that shaped the solar system billions of years ago. The initial crater, formed in the first few seconds of the impact, would be a deep, bowl-shaped chasm driven dozens of kilometers into the Martian crust. The sheer force of the impact would vaporize and melt trillions of tons of rock, creating a temporary sea of magma at the epicenter of the collision, a violent and ephemeral feature in the newly formed landscape. In the moments following the initial impact, the transient crater would begin to collapse under the planet's own gravity. The rim would slump inward, and the compressed rock at the crater's floor would rebound, thrusting upward to create a massive central peak or a complex ring of mountains. This entire violent process of excavation and modification would be over in a matter of minutes, but it would leave a permanent and monumental feature on the face of Mars, a 60-kilometer-wide testament to the energy of the collision, a circular wound that would be visible from orbit for eons to come. The creation of such a crater would be a geological event of the first order, instantly erasing eons of Martian history at the impact site and excavating material from deep within the planet's crust. This newly exposed rock would be a treasure trove of information about the planet's deep geology, but it would be a book written in the language of utter devastation. The simulations were clear. The arrival of Atlas would not just be an impact, but an act of violent and instantaneous geological creation, leaving a permanent and colossal monument to its passage. The consequences of the impact, as detailed by the simulations, extended far beyond the immediate creation of a 60-kilometer crater. The event was predicted to be so powerful that it would permanently alter the fundamental geology and atmosphere of Mars on a global scale. The initial shockwave would not simply travel across the surface, it would propagate deep into the planet's interior, sending a seismic pulse of unimaginable force through the mantle and core. This would be a planetary convulsion, a singular event with the power to rewrite the geological state of the entire world in a matter of hours. The immense seismic energy unleashed by the impact could trigger a cascade of geological reactions across the planet. It was theorized that the shock could reactivate ancient, long-dormant volcanoes, leading to massive eruptions that would vent even more gas and dust into the sky. Vast, unstable regions like the Valles Marineris Canyon system could experience catastrophic landslides, reshaping landscapes thousands of kilometers from the point of impact. In essence, the collision would act as a planetary reset, violently rearranging the geological equilibrium that had been in place for millions of years. Simultaneously, the impact would have a profound and immediate effect on the fragile Martian atmosphere. The collision would vaporize trillions of tons of rock and any subsurface ice deposits, ejecting a colossal plume of superheated dust, water vapor, and carbon dioxide high above the planet's surface. This ejected material would rapidly encircle the globe, creating a planetary dust storm of a density and duration that would dwarf any previously observed weather event. The sun would be completely blotted out from the Martian sky, plunging the entire planet into a deep, cold twilight that could persist for years. Beyond the immediate darkness, this massive injection of material would permanently transform the composition and density of the Martian atmosphere. The sudden influx of vast quantities of greenhouse gases, primarily water vapor and carbon dioxide released from the crust, could trigger a runaway climatic shift. The atmospheric pressure at the surface could increase significantly, and the planet might experience a brief, chaotic period of warming. The thin, cold, and stable atmosphere that had characterized Mars for eons would be gone, replaced by a new, thicker, and far more unpredictable climatic regime, a permanent and violent alteration of the Martian environment. As the chilling consensus of the impact simulations solidified into an undeniable truth, the data began to move through secure channels, connecting the world's leading space agencies in a shared sense of profound alarm. The numbers, 10 billion tons, 57 kilometers per second, 2 million megatons, transcended language, politics, and national interest. They described a planetary-scale threat that rendered all terrestrial concerns insignificant. In the face of such a clear and impartial danger, a historic and necessary process was set in motion as the European Space Agency, Russia's Roscosmos, the China National Space Administration, and the Japan Aerospace Exploration Agency recognized the absolute imperative for a unified global response. In an unprecedented act of international cooperation, an emergency meeting was hastily convened. This was not a scheduled conference or a diplomatic formality, but an urgent virtual summit that brought together the planet's foremost experts in astronautics, planetary science, and orbital mechanics.
The usual currents of geopolitical competition and scientific rivalry were suspended, replaced by a shared and sobering purpose. For the first time in history, these powerful and often competing organizations came together not as representatives of their nations, but as stewards of humanity's collective presence and future in the solar system, united by a singular, existential problem.
The primary agenda of this emergency session was twofold. The first order of business was a stark and sober verification of the threat, as each agency independently presented and cross-referenced its own tracking data and impact models. As every analysis confirmed the catastrophic predictions, the focus pivoted immediately from assessment to action. The discussion shifted to the monumental task of inventorying humanity's entire arsenal of space-based capabilities, evaluating every probe, satellite, and theoretical defense concept that could possibly be brought to bear against the approaching object. The meeting concluded not with a simple agreement, but with a historic and unified resolve. The shared understanding was that this was a challenge that no single nation could or should face alone. It was a threat to a world that humanity had long considered its next frontier. This unprecedented cooperation was more than a strategic alliance. It was a necessity born of a shared and dire peril. The decision was made to formalize this collaboration, to create a single, unified entity that could coordinate a global response with the speed and authority that the crisis demanded. From the historic consensus of the emergency meeting, a new entity was born. A unified command structure designed to marshal the full extent of humanity's resources. It was officially designated the ISO Object 1 Task Force, a deliberately neutral and functional name, with ISO standing for Interstellar Object. This was not a subcommittee or an advisory panel. It was an operational body with unprecedented executive authority, created for the sole purpose of coordinating a global response to the impending Martian impact. The core mandate of the ISO Object 1 Task Force was absolute and unambiguous: to devise and execute a plan to neutralize the threat posed by Atlas. The task force was structured to facilitate the rapid, unrestricted sharing of data and resources, breaking down the institutional and political barriers that had long defined international space exploration. It was composed of the most brilliant and experienced mission planners, engineers, and planetary scientists from each participating agency. A global brain trust assembled to solve a problem that threatened to erase humanity's future on another world. This new level of collaboration was put into practice immediately, as decades of classified protocols and proprietary technologies were opened up for the common cause. The deep space communication networks of all member agencies were integrated, creating a single, robust system for tracking the object and communicating with assets across the solar system. Propulsion experts from Roscosmos worked alongside navigation specialists from JAXA, while ESA's material scientists shared data with CNSA's orbital dynamicists. It was a seamless and continuous flow of information, a collective intellectual effort focused with singular intensity on the approaching object. The weight of responsibility placed upon the shoulders of this newly formed group was immense. In their hands lay the fate of Mars, not just as a celestial body, but as a symbol of human aspiration and a potential future cradle for life. They were tasked with protecting the priceless scientific outposts that were already on the planet's surface, and safeguarding the integrity of a world that had captivated the human imagination for centuries. The establishment of the ISO Object 1 Task Force was the ultimate acknowledgement of the crisis's magnitude. A moment when humanity looked beyond its terrestrial divisions to act as a unified, spacefaring civilization. With the formation of the ISO Object 1 Task Force, the full scope of the challenge became terrifyingly clear, and no aspect was more daunting than the timeline. The immense velocity of ATLAS, compounded by its ongoing controlled acceleration, meant that the window of opportunity for any effective countermeasure was not measured in months or weeks, but in mere days. The object was not slowly drifting into a collision course, it was closing the remaining distance to Mars with astonishing speed. each passing hour bringing it thousands of kilometers closer and dramatically narrowing the geometric possibilities for interception. This was not a problem for the future, it was a crisis in the immediate present. The daunting physics of the situation placed almost insurmountable constraints on any potential response. Intercepting an object traveling at 57 kilometers per second is a feat of celestial mechanics, far beyond anything humanity had ever attempted. A mission could not simply be launched at the object. It would have to be placed on a perfect trajectory to meet it at a precise point in space and time, requiring a launch with almost no margin for error. The sheer energy and precision needed for such an intercept mission, planned and executed in a matter of days, pushed the very limits of known rocketry and navigation technology. This extreme time pressure forced a dramatic shift in the task force's operational focus. The period for deliberation, for designing new technologies or debating theoretical solutions was over before it began. The ISO Object 1 team was locked in a frantic race against the clock, forced to work exclusively with the tools and assets that were already available. The conversation was no longer about what was possible, but about what was immediately deployable. Every option had to be evaluated, not just for its effectiveness, but for its readiness, as the countdown to impact continued with relentless and unforgiving certainty. The world's collective scientific and technological might was now focused on this incredibly narrow sliver of time. The fate of Mars, the preservation of decades of scientific exploration, and the success of this unprecedented global alliance would be determined by the actions taken within this fleeting window. The problem was no longer one of understanding the threat, but of executing a solution under the most extreme pressure imaginable. The clock was ticking, and the final opportunity to act was slipping away with each rotation of the Earth. While the ISO Object 1 task force worked frantically on a space-based solution, the focus of the crisis also turned to the only permanent residents of the Red Planet, humanity's robotic emissaries on the surface. On opposite sides of the globe, NASA's Perseverance rover in Jezero Crater and the China National Space Administration's Zhurong rover in Utopia Planitia had been dutifully carrying out their scientific missions, searching for signs of ancient life and mapping the planet's geology. In an instant, these missions of discovery were suspended, their priorities completely rewritten by the approaching cataclysm. They were no longer just explorers, they were now our frontline observers, the only ground-based witnesses to the unfolding event. Placing these rovers on the highest alert was a complex procedural and technical undertaking. All non-essential scientific activities were immediately halted to conserve power for the systems that mattered most: communications, environmental sensors, and their powerful camera suites. Their operational software was updated remotely with new command sequences, transforming them from methodical geological surveyors into dedicated sentinels. Their new directive was to continuously monitor the Martian sky and environment, programmed to capture any and all data related to the object's final approach and the immediate aftermath of the potential impact. This retasking represented yet another unprecedented level of international cooperation, coordinated through the ISO Object 1 task force. Data streams from both Perseverance and Zhurong, once the exclusive property of their respective agencies, were now integrated and shared in real time. Their disparate locations provided a crucial planetary baseline, allowing for a comprehensive ground-level view of the crisis. Together, they formed a rudimentary planetary sensor network, their instruments calibrated to detect the subtle atmospheric changes, seismic tremors, or acoustic signatures that might precede the final impact. In their silent, lonely vigil, these two marvels of engineering assumed a new and somber role. They were humanity's proxies, our eyes and ears on a world facing imminent devastation. Their survival through the cataclysm was highly uncertain, but their final duty was to bear witness. The data they might transmit in the last moments, the initial flash on the horizon, the arrival of the seismic shockwave, the sudden spike in atmospheric pressure, would be their final, invaluable contribution to science. They were silent sentinels, standing ready on the plains of Mars to document the end of an era. Ultimately, the profound unpredictability of the situation stemmed from two inseparable factors: the object's active, intelligent guidance and its immense velocity. Every predictive model humanity had ever built was based on the foundational principle that celestial bodies obey the laws of physics. But Atlas was not a passive subject of these laws. It was an active agent, capable of making its own decisions. This single fact rendered all long-term interception plans profoundly unreliable. The task force was not calculating the trajectory of a rock. They were attempting to anticipate the strategy of an unknown and silent intelligence, an opponent that could change its course at any moment, for reasons that remained a complete and terrifying mystery. This fundamental uncertainty was terrifyingly amplified by the object's incredible speed. At 57 kilometers per second, the time between any potential maneuver and its final consequence was almost zero. There was no room for observation, reaction, and correction. A last-minute change of direction by Atlas, even a minor one, would be impossible for any human-made interceptor to counter. The sheer velocity was a tactical advantage of the highest order, a physical constant that guaranteed the initiative would always remain with the approaching object. Humanity was perpetually on the defensive, forced to react to a timeline set not by the laws of gravity, but by the will of the visitor. The combination of these two elements, active steering and high speed, created a strategic environment of absolute helplessness. Every plan formulated by the ISO Object 1 task force, every desperate strategy debated through the long hours, was built upon the fragile and unprovable assumption that the object would maintain its current course. They were forced to aim at a target they knew could move, to gamble the fate of a world on the hope that their silent adversary would not make another unpredictable turn in the final hours of its approach. This was not a problem of physics, but a confrontation with a superior will.